Welcome to the Math Hacker. Today I'll be covering the ICTM State 2017 Division A Algebra 2. I'll be going through every single question from 1 to 20 in that order, and if you want to look for a specific one, it's going to be timestamped in the description. Okay, number 1. Determine the order pair xy that's the solution to 3x plus y is equal to 5 and 2x minus y is equal to 0. Find the order pair xy. So since it's already in plus y and minus y, we could just use elimination and add them together. So then 3x plus 2x is 5y to 5x. The y's cancel out and this adds up to 5. So x is equal to 1. Plug it back into the first equation. That's 1. So that's 3. 5 minus 3 is 2. So our answer is 1 comma 2. Okay. And delete the rest of this. Cool. Number 2. Determine the sum of all distinct values for x such that the square root of 2x minus 12 is equal to x minus 10. So square both sides, so 2x minus 12 is equal to x squared minus 20x plus 100. So x squared minus 22x plus 112 is equal to 0. And that factors out to x minus 8 and x minus 14. Right, so x equals 8 or x equals 14. So usually for radicals, only one of them exists. And the one that exists is 14 only. And the reason is because 8 minus 10 is equal to negative 2. And square root of something cannot be negative, so it cannot be 8. So the only answer for number 2 is 14. Okay, number 3. Determine the value of k such that 16 to the power of k times 8 to the power of k plus 3 divided by 32 to the power of k minus 1 times 4 to the power of k times 2 to the power of 4k is equal to 32 to the power of 4. Okay, so using exponent rules, basically anything with the same base when you're multiplying is going to be actually adding. So it's going to be 16 is 2 to the power 4, so 4k, and 8 is 2 to the power 3, so that's 3k plus 9. And then when you're dividing, you're subtracting, so minus 2 to the power of 32 is 2 to the power 5, so that's 5k minus 5. And that's going to be 2 to the power 2, so that's plus 2k. And that's already in 2, so that's plus 4k. And that's all equal to 32 to the power 4. 32 is 2 to the power 5, so 5 times 4 is 20. Right, so they're all in base 2. Okay, so 20 is equal to 7k plus 9 minus 5, 7, 11, so 11k minus 5. So 20 is equal to, or negative 4k plus 14. So that means negative 4k is equal to 6. That means k is equal to negative 3 over 2 as your answer for number 3. Okay, it just takes a while. Okay, number 4. Let y equals log 4 of 8 times 2 to the power x. Then y equals k parentheses x plus w. Find k plus w. Okay, so let's write that out. Log 4 of 8 times 2 to the power of x. So that's the same thing as y is equal to log 4 of 8 plus log 4 of 2 to the power of x. We could take out the x and put it in the front, so x times. So then you have x is equal, y is equal to, what's log 4 of 8? Well, log 4 of 8, let's just use a, so 4 to a is equal to 8. So 2 to the power 2a is equal to 2 to the power 3. So a equals 3 over 2. Okay, so this is 3 over 2 plus x, and what's in front of that? Well, log 4 of 2. What is that? What's log 4 of 2? Well, 4 to the power of a is equal to 2. 2 to 2a equals 2 to the power 1, so a is equal to 1 half. So distributing out the 1 half, that's x plus 3. So our k is 1 half and our w is 3, so adding those together is 7 over 2. And just your answer for 4. Number 5, 147 divided by square root 10 minus square root 3. And we have to find it in the form k squared p plus w squared q. And then find the exact sum, k plus w plus b plus q. So square root 10 plus square root 3 square root 10 plus square root 3. And the reason I did that is that whatever's the sign right here, you gotta do the opposite of that. So if it's negative, you gotta put positive. If it's positive, you put negative. So in this case, it's negative, so you put positive. So then 147 times, we're not gonna simplify this one just yet, so square root 10 is square root 3. And then square root 10 times square root 10 is 10. Square root 10 times square root 3 is negative square root 30. And negative square root 3 times square root 10 is negative square root 30. So then those cancel each other out, and then square root 3, negative square root 3 times square root 3 is negative 3. So 10 minus 3 is 7. So 147 divided by 7 is 21. So then 21 distribute out to both of them, so that's 21 square root 10 plus 21 square root 3. So 21 plus 21 is 42. 42 plus 3 is 45, and then plus 10 is 55. And that is your answer for number 5. Number 6, determine the sum of all real roots for the equation 6x cubed minus 25x squared minus 76x plus 60 is equal to 0. Determine the, okay, so express your answer. Okay, so usually you don't have to read the entire thing. Sorry if I keep pausing and reading it. And 76x squared plus 60 is 0. Right. Okay. So the trick to this is that you could actually just take the second coefficient, multiply by -1, and then divide by the first coefficient. So that will be always the sum of the real roots. So it's just -1 times -25, because that's your second, and then divide your first, which is 6. So that's 25 over 6. And that should be your answer for number 6. It should just be that simple. It's just a really neat trick. Number 7, determine the area enclosed by the graph of the inequality absolute value 3x minus 12, close absolute value, plus absolute value 2y plus 4, close absolute value, divide less than or equal to 3. So to find the graph of this, you actually need to understand how it looks like, and it's actually just going to be a diamond. So how do we find the area of this diamond? Well, what you need to know is that these two numbers actually don't matter. And the reason is these two numbers just tell us where it's positioned. So what it kind of means is that like instead of being right here, like right at the center, maybe it's gonna be like somewhere like right here, right? It doesn't matter because the area is gonna stay the same. It doesn't matter where it's gonna be positioned. If it stays the same, the area stays the same. So we could just ignore these two. So now we have to find the upper and lower bound. So lower x, upper x, lower y, upper y. So 3 goes from -3 to 3, right? Because it's absolute value. So then -3 divided by 3 is -1. 3 divided by 3 is 1. -3 over 2 divided by 2 is -3 over 2. And 3 divided by 2 is 3 over 2. So the distance in the y is 3, right? Because 3 over 2 minus -3 over 2 is 3. And then the distance of x is 2, right? So 1 minus -1 is 2. So the distance of x times the distance y times a half should be the area. So that's 3. Okay, that's just the usual formula for a diamond. So that's the answer for number 7 is 3. Number 8. 3 times the larger of two numbers. Okay, let me move it down a little bit more. So 3 times the larger of two numbers. So we have two numbers, a and b. So 3 times the larger is 6 less. So to get it equal to each other, you gotta add 6. Then 10 times the smaller. And they say the difference between the two numbers, so b minus a, remember b is the bigger one, so that's equal to 5. So rewriting that, that's good. B equals 5. B minus 5 is equal to a. So you can substitute a in here, so that's 3b plus 6 is equal to 10b minus 50. So that gives us that 7b is equal to 56. That means b is equal to 8. Plugging it back into here, that means a is equal to 3. So we need to find the sum of the two numbers. So 8 plus 3 is 11. And that's your answer for number 8. Okay, number 9. Let x equals the infinite radical of 2017. So x is equal to k plus p squared w divided by q. Find k plus w plus p plus q. Okay, so what you need to know is where does this pattern repeat? So if you put a plus x here, plus x. So the reason I did that is that this entire radical repeats again right here. right? It's kind of hard to like show it, but yeah, highlight it. But like it repeats right here, so you could just substitute it in. It also repeats right here, but that's usually inconvenience because then you have to find the radical inside a radical, which takes a little bit longer, but it's gonna give the exact same answer. So usually you just do this and it should be fine. Then x squared is equal to 2017 plus x. So x squared minus x minus 2017 is equal to 0. So using your quadratic formula, which is negative b, plus or minus, it's not going to be minus because it's going to be, because then this becomes negative, which is not possible. So negative b plus b squared minus 4ac. So minus a negative positive, so 4 times 2017 divided by 2a. And a is just 1, so it's just 2. So 1 plus square root. So that's 8068 and then 8069 divided by 2. So our K is 1, our P is 1, our W is 8069, and our Q is 2. So adding them all together, that's 1, 2, 4, plus this is 8073. So 8073 is your answer for number 9. Okay. This question usually appears quite a bunch in a bunch of math competitions. You might want to know how to do these generally. Number 10. Bob eats lunch at McDonald's or Burger King every weekday according to the following pattern. When Bob eats at McDonald's, so when he eats at McDonald's, the probability that he eats McDonald's the next day is 70%, so 0.7. So that means if he eats McDonald's, that means if he wants to eat Burger King's, that means it takes 30%. And when he eats Burger King and he eats at Burger King the next day, it's going to be 80%. That means if he eats Burger King and he wants to eat McDonald's next day, it's going to actually take 20%. Okay. So Bob ate lunch at Burger King Monday. So he ate Burger King. So on Monday, he ate Burger King. So Monday. So according to this pattern, determine the probability Bob will eat McDonald's on Friday. So what's the probability that he eats McDonald's on Friday, such that he eat Burger King on Monday? So since we're 5 days apart, I mean 4 days apart in a way. So XXXM. Right, so from here to here, that's 1, that's 2, that's 3, that's 4. So we're gonna have use 4 of these probabilities. So we could just make a tree of how this works. So let's kind of delete this so I get a little bit more room. So since we started with Burger King, we have to start with the B's. So it's 0.8 and 0.2. So burger for the 0.8, it ends with the Burger King, so we have to start with the Burger King. So 0.8 and 0.2. And then 0.2 ends in the McDonald's. So we have to start with McDonald's, which is 0.7, 0.3. Okay. So 0.8 ends with a Burger King, so we start with Burger King, which is 0.8 and 0.2. So this one ends with McDonald's, so it starts with McDonald's, so 0.7, 0.3. Okay. So this one ends with McDonald's, so we gotta start with McDonald's, 0.7, 0.3. And it ends with Burger King for 0.3, so we have to start with Burger King, which is 0.8 and 0.2. Right. So remember, this is gonna end. So this from Monday to Tuesday. So Tuesday to Wednesday and Wednesday to Thursday. So now we're gonna end at Friday. So we only have one more date. So there's only 8 possibilities. So where are so if it's 0.8 and we need to get to our McDonald's, right? We're now at Burger King. To get to McDonald's, from Burger King to McDonald's, 0.2. From 0.2, that's McDonald's. From McDonald's to get to McDonald's, that's 0.7. Okay, so we're at McDonald's again. To get to McDonald's, that's another 0.7. And we're at Burger King. To get to McDonald's, we had to use 0.2, right? And this numbers usually repeat, so we could just do it again. So 0.7 goes with 0.7. 0.3 goes with 0.2. 0.8 goes with 0.2. And 0.2 goes with 0.7. Okay, so now we have to multiply all these 8 possibilities and find out what it comes up to, right? because there's one line right here, there's another one right here, another one right here, and then another one right here, right? And then there's another tree right here. So there's a total of 8. So all you have to do is just multiply the numbers out. So we're just gonna multiply the integer parts and then just divide by 10,000. It's the same thing. So 8 times 8 times 8 times 2, that's 1,024. So 1,024. And then 8 times 8 times 2 times 7, that's 896. Then we have 8 times 2 times 7 times 7, which is 784. And we have 8 times 2 times 3 times 2, which is 96. 2 times 7 times 7 times 7, 686. 2 times 7 times 3 times 2, which is 84. And 2 times 3 times 8 times 2, which is 96. And 2 times 3 times 2 times 7, which is 84. Okay, so now add all those numbers up. So 1024, 896, 784, plus 96, plus 686, plus 84, plus 96, plus 84. And you should come out as 3,750. And then we need to divide that all by 10,000, right? Because they're all scaled down by 10,000. I mean, by 10,000, right? So then we have to move 4 decimal places, so that's 0.375. And that is your answer for number 10. It just takes a while because you got to find out all the possibilities. Okay, number 11. The graph of an ellipse with center 7, 2 is tangent to the x-axis at 7, 0 and y-axis at 0, 2. So let's say this is 7, 2. So it's tangent at 7, 0, so right here, and tangent at 0, 2 right here. So that means the distance from here to here is 7. This is here is 2. So ellipse looks something like this. So to find the exact area of ellipse, it's just one length times the other length. So 7 times 2 is 14 times pi. So that's your area. It's the same thing as like circle, which is pi radius squared. But now the radius is not the same the entire time, right? Because now it's 2 and 7. Okay. Number 12. I equals the square root of -1 and a equals all of this raised to a power. So determine the exact value of a. Okay, so for number 12, all I need to do is a equals. So the pattern with i's is that it actually starts repeating with powers. So 4. So I is just I squared is just -1 because I is square root -1, right? It's given 12. And then I cubed would just be -1 times I, so negative I. And then I4 would be -1 times -1, which is 1, right? So then when you add all these 4 together, that means this cancel with this and this cancel with this. So every single 4 numbers, they're going to cancel with each other. So what this tells us is that if it goes from 1 to 2017 for exponents, right, as shown in the question, 1, 2, 3, 4, 5, etc., all the way to 2017, that means every single 4 multiple cancel each other. So 2017 divided by 4, that's really close to 2016, right? 2016 is divisible by 4. So so that tells us that all the numbers, so that's going to be 5,004, 504, and then 1/4. So it repeats, so there's so the numbers cancel each other out each time 504 times. And then we have one remaining, which is the last one, the 2017. So I to the power of 2017, right? That's just the first term because it's right here, the first one. So what's the first one? I negative 1, and then it's going to negative I, and then 1. So the first term is I. So that's what it concludes to. Okay, so that's number 12. Number 13. Let m be a non-zero real number such that the positive difference between the roots of mx squared plus 5x minus 6 equals 0 is 1. Okay, determine the sum of all possible values of m. So they said that the difference between the two roots is 1. So you can write m because we keep the coefficient front the same. So x minus a. So that's our first root. So our next root has to be a plus 1 equals 0, right? Because the roots are one difference apart. So then expanding this out, that's mx squared minus a a plus 1 is 2a plus 1 x. Sorry about that. And then plus a plus 1 equals 0. So all those had to correspond to each other. So m 2a plus 1 equals our negative 5, right? This is negative right here. And then we have a plus 1. That's positive and this negative, so this one's going to be negative 6. So to cancel our m, because we have to find a first, so let's move that so we get a little bit more room. So divide both equations by each other. So we have 2a plus 1 divided by a plus 1 equals 5 divided by 6. So cross multiplying, that's 5a squared plus 5a equals 12a plus 6. So 5a squared minus 7a minus 6 equals 0. And there's only one way to really factor it. So 3 and 2, 3 is too big, so minus 2 and plus 3. Right, so that's negative 10, and then plus 3, negative 7. Perfect. So a is equal to 2, or a is negative 3 over 2. So we're not looking for a, we're looking for m, right? So we have to plug it back into one of these equations. So let's use this one because it's a lot easier to use. So if a is equal to 2, that's 4, and then plus 1 is 5. So negative 5 divided by 5 is negative 1. So in this case, m is equal to negative 1. Okay, now negative 3 over 2. Negative 3 over 2 times 2 is negative 3. Okay, so, oh, sorry, not negative 3 over 2. This is negative 3 over 5. Sorry about that. So for this m, negative 3 over 5 times 2 is negative 6 over 5 plus 1. 1 is just 5 over 5, so negative 6 over 5 plus 5 over 5 is negative 1 over 5. So then multiply both sides by negative 5, that's 25. So m equals 25. Right, so you just do a little bit of mental math. So that means the sum of all possible values is 25 plus negative 1 is 24. And that is your answer for 13. Got it. 14, in a geometric sequence a of 1, so our first one, so 1 is 5 over 4. And our fourth one, so 1, 2, 3, 4. And then our fourth one is negative 10. And we need to find our third one right here. Okay, so how do we get from 5/4 to negative 10? So since we have to get from a positive negative, that means there must be a negative somewhere. And since we need to cancel out a 4, that means we're either using 4s and 2s. So from 5 to 10, that's a 2, so we're going to be using 2s. So it's going to be negative 2, right? Because negative 2 to the power of 3, that's negative 8. Negative 8 times 5 over 4, that's negative 10. So our ratio is negative 2. So to get to 3, we just need to divide by our negative 2. So negative 10 divided by negative 2, that's equal to 5. So that's our answer for number 14. It's just basically that simple. There's multiple ways to do this. It's going to get the same answer. Number 15, determine the value of 3k minus w, where k and w is the solution for x, y for this. Okay, so 4x plus 6y is equal to 2, and 6 over x plus 3 over y is equal to 4. So a way to think about this is imagine 1 over x is equal to a, and 1 over y is equal to b. So 4a plus 6b is equal to 2, and 6a plus 3b is equal to 4, right? Now it's a lot easier to work with because now it kind of looks sensible. So let's multiply both sides, this side by negative 2, and then add to the first one. So that's negative 12 plus 4 is negative 8a. So negative 6 plus 6 cancel each other out, and that's negative 8 plus 2 is negative 6. That means a is equal to negative 6 divided by negative 8 is 3/4. So doing that, we need to find b, so we can plug it back into, let's say, the first equation. So 4 times 3 over 4 is 3, so 2 minus 3 is negative 1, so b is negative 1 over 6. So to find our x, we just do reciprocal of x and y. We just do a reciprocal of these, right? Because 1 divided by a is x and 1 divided by b is y. So this one's going to be 4 over 3. So x is equal to 4 over 3, and our y is equal to negative 6. So to find 3k minus w, we just have where k is equal to x and w is equal to y. So 3 times 4 over 3 is 4. and then minus w, so minus 6 is plus 6 is equal to 10. Oops, sorry. Okay, so our answer for number 15 is 10. Okay, just a few more to go. Let a squared plus ab plus b squared is equal to the cube root of 25 plus the cube root of 10 plus the cube root of 4. Find the exact value of positive difference of a cubed minus b cubed. So what you need to know is that it's actually kind of simple. So since we could just ignore the cube and think about 25, 25 is just 5 squared. Squared. That's a coincidence, so a is going to be equal to 5. But it's not exactly 5, it's 5 to the power 1 over 3. Because this is the cube root of 5, right? The cube root of 5, and then a squared would then be the cube root of 5 squared, which is just 25, which matches with this one. And that's why I say it was kind of a coincidence. So what will our b be? Well, we just look at this one then, right? It's kind of seems to like all these three terms kind of match each other. This one matches with this one matches with this one matches with this. So we just like do a quick method and not doing any like rough math and just do this. So b squared, so b4 is just 2 to the power 2. So that's just 2 power 1/3, right? So 5 1/3 and 2 1/3. So that means a to the power 3, so 5 1/3 to the power 3 is just 5. And 2 1/3 to the power 3 is just 2, so 5 minus 2 is 3. It's just that simple for 16. 17. Let n be a positive integer such that n is greater than 1,000. So n is greater than 1,000. And let k be a positive integer. So k is greater than 0. And they're both integers. Let n plus 1 be a number that divides the group of n plus 1. And I mean n plus k positive integers into groups such that the group less than n plus 1 has the same sum as the group of integers that is greater than n plus 1. Determine the smallest possible value of n. So there's n plus k. There's a equals the number of equals the number equals the amount of numbers, right? A number of terms, let's say. So we have n plus 1 right in the middle, and then everything less than that, and everything greater than that is on the side. So the sum here is equal to the sum here. So the answer to this is actually kind of I guess simple because if we have to find the smallest possible value of n and n has to be greater than this, then the smallest, which is an integer, is 1001. And that's your answer for 17. And the reason is because it's actually never specified in 17 um like what the elements of the group are. Because they said there were two groups of group of positive integers, but we don't know what those integers are, so we can't really put anything. Because theoretically, if we said our n was 1001, right? And let's just say our k is equal to 1, right? Let's say k is equal to 1. Then it's got to go to 1002. So we have 1002 terms. So actually, let's do a little bit. Let's say k is equal to 2 instead. We'll actually do some math with this. So if it happens at least once, then it's going to be an answer because it says small as possible, so it's possible. So k is equal to, oops, sorry, what did I put? And then, so the number of terms is 1003. So let's say, so it's going to split from 1002, right? That's why I chose 2 here, so that makes 1003, right? So that's the only number that's really big, bigger than 1002. So then if that's possible for 1003, that means n plus k, which 1001 plus 2 is 1003, right? If 1003 is our biggest, that means we have 1002 more terms left. We could just think about 1001 ones, right? So that adds, so all those ones, if we have 1001 ones, then that just adds up to 1001. So you could just have the last term because we need 1002 terms, right? 1002 terms. So that means that you could just have the last term a 2, and that adds up to 1003. Because these 1 and 2 is definitely smaller than 1002. So the answer for this question is just 1001. I guess it's just not specified, but it's if it's not really specified and has these long paragraphs, sometimes it's just a really easy question because they might have forgotten to put something, and it's just that. Okay, number 18. The endpoints of the lattice rectum of a parabola are negative 2 and 2. So negative 2, 2. So negative 2, 2. And 10, 2. Okay, so that's 10, negative 2, 2. That looks bad. So, and the directrix is y is equal to k. Find all possible values for k. So a lattice rectum is basic. I'll just draw the parabola out first. So there's two of them, right? You can either go concave up or concave down. So let's work with concave up first. So the directrix of a concave up is going to be in this way. So what it means to be a lattice rectum is that there's 2 points that makes up the lattice rectum. And then when we draw a line between it, find the halfway mark and then go down. This length is equal to this length. Okay, so there's 3 of them. So each of these 3 lengths are the exact same. So negative 2 to 10 is 12. So that means this distance is 6, this distance is 6, and this distance is 6. Uh, right? And this one is at R2. So our height is at 2 right here. So at this point, negative 2 plus our 10 is 8. 8 divided by 2 is 4. So right in the middle, right here, is 4 comma 2. And we have to go down 6. So it's going to be 4, negative 4. Okay. So, okay. So then when we're kind of, oops, sorry about that. Oops, I said that wrong. The lattice rectum is actually twice the distance, so that's 6. That's 6. And then this is 3. Sorry about that. So these distance are the same. I just can't draw. Sorry about that. So then when we're moving 3 here, the distance from this is the foci. So a lattice rectum is from 2 points of a parabola from the foci to the each of the side of the parabola, and then from the focus down here to this point is the vertex, and then the vertex to the directrix, they're the exact same distance. So that's 3. So then when we had to find the point, this was 4 comma 2, I believe. I forgot. Yep. Then we had to move 3 and then another 3, which moves 6. So that's 4, negative 4. So then when we're moving concave up, it's just the same thing, which is right here. So it's going to be up here. So then this one moves 3 up, right? Because it's the same distance, half of this one. And then move 3 up here. So that's plus 6 now. So then it'll be 4. Plus 6 to the 2 is 8. So it doesn't matter what this point is. So it's just going to be negative 4 and 8 because that's where our y is equal to 2. So then our 2 points is negative 4 and 8, which is our answer for number 18. Okay. Number 19. Determine all possible values for x such that the absolute value of x plus 2 plus the absolute value of x is equal to 8. So find all possible values. So if x plus 2 was positive, we just leave it x plus 2 plus absolute value of x is equal to 8. Or if this is negative, we got to multiply this by negative. So it's got to be x plus 2 negative absolute value of x equals negative 8. Right? So then that tells us that if we want to keep the absolute value of positive, that's 8. 8 minus 2 is 6, then minus x. Then move the absolute value on the other side, so make that positive. So x plus 2 plus that 8 is x plus 10. So it can't be positive x and positive x here, so it doesn't work. So this has to be a negative x. So negative x equals x plus 10. In the same case here, so it can't have negative x and negative x here, so that has to be positive x. So that means for this x is equal to 3. And for this x, that's equal to negative 5. So our two possible answers is 3, negative 5. Okay, should be pretty simple. Just a simple absolute value question. Number 20. the sum of the lengths of two legs of a right triangle is 49. So let's kind of draw a picture up. So A, B, and C. So the sum of the lengths of the two of them, so A plus B, is equal to 49. And the sum of the numerical length of the hypotenuse square, so C squared is equal to 1225. And determine the area of the triangle. So we have to find A, B divided by 2. So instead of finding A and B and C, what we could do is actually do some math. So we could just do A plus B squared. What does that come out to? Well, that's just A squared plus B squared plus 2AB, right? So we know A squared plus B squared is equal to C squared, right? So to just get this part, we need to minus the 2AB. So for this part, we could just minus 2AB, and that will give us our C squared. So if this is equal to C squared, we just plug in every single number we know. So we know AB, which is 49, so 49 squared, and then minus 2AB is equal to C squared, which is 1225, right? So 49 squared minus 1225 divided by 2 is equal to our AB, right? We need AB divided by 2. So we don't actually have to look for A and B. We just need to get those terms. So to get AB divided by 2, we just need to divide this by 2. So we need to divide this by 2. So then our area is 49 squared minus 1,225 divide by 2 again, which is 294, which is your answer for number 20, right? So it's just sometimes really just that easy. You don't have to actually look for all these numbers. You just like manipulate your variables around so then they could work really well for you. And that basically completes everything for our ICTM 2017 Division A Algebra 2. So based on what we need to know, no triangles, no absolute values, no conics, not just parabolas, so like ellipses and it's not shown here, but also hyperbolas. Sometimes tricks, you do not need to always, if it's long, you don't always might not need to solve it because it might have some errors in there. And sometimes you want to think about things in a different way like this and know like your sequences like geometric and arithmetic or harmonic. No complex values, so anything from pre-calculus is good. And then basic probability, radicals, right, and exponents. Well, thanks for watching, and I'll see you at the next math record.